Okay, so I would say the next thing we need to look at is the debug of the routing table. We need to figure out what specifically is changing. And the way we can see this is simply to debug IP routing. Okay, so we're going to look at this on the customer edge, and then we're going to also look at this on the provider edge. So debug IP routing, same thing on a 1, 2, and 3. Okay, let's just say it on all of these. Debug IP routing. Okay, from router 7's point of view, it says that something is changing. We added a specific network, then we deleted the subnet, but it doesn't really tell us why that is the case. Okay, the only thing we see is that the route is changing between being added and being deleted. What we need to figure out is what is the router that is specifically deleting the route and why. So from 7's point of view, there's only one way that we can get this update. The update has to be coming in from router 3 because that's the PE router. So let's go up to router 3 and look at the same thing. And it says we're adding the route because of what? It says we had a closer administrative distance. That we're adding the route through BGP, and then we found a closer administrative distance through what? The closer distance must be through ISIS. Here's the issue. Closer administrative distance for 10.1.10. We're adding it with the distance of 115, and then it's getting deleted and then adding as BGP. Now, if this was OSPF again, we would never see this problem, because why? Because when we redistribute from BGP into OSPF, we're sending the downward bit. Then if the route comes back to the PE router, we know not to install it into the routing table. But in this particular case, ISIS doesn't implement any type of loop prevention like that for MPLS. And additionally, what we're doing here is running both level 1 and level 2 at the same time. So this means that router 10 is a level 1 and level 2 router. So basically what's happening is that router 10 is advertising the route into ISIS, and we're redistributing it into BGP. Okay, it's going over from router 1 to router 2. It's going over from router 1 to router 3. Router 2 is then redistributing the route back into the ISIS process. Now, if we look at from router 1's point of view, let's do an undebug here, and let's see what happens when we show IP route for VRF-B for 10.10.10.10. And let's see specifically what is changing about the route. So show IP route for VRF-B for 10.10.10.10. Okay, we're learning it as ISIS level 1. Which it looks like this route is stable because notice the timer here. The timer is about 17 minutes. Okay, so let's check for another route. Show IP route VRF-B for 7777. This is definitely going to be a problem. Notice here that the timer was only 2 seconds when I was looking at the route to begin with. So something is changing specifically about this prefix. So notice here it says, I know the route via 10.1.10.10. It says it's known via ISIS level 2. Then after we flush it out, it's known via router 2 as a BGP route. Okay, if we keep looking at this, eventually we should see that sometimes this is going to be reachable via router 3. And let's look at the same output from router 2. And what I want to see is what happens when it changes between the two protocols. This is what the issue is. It's changing between levels. So it says first I knew it as a level 1 route, then I knew it as a level 2 route. And the order of this is going to be kind of dependent on how you actually did the redistribution. Like if you clear the routing table, the problem will happen on the other side. But essentially what the problem is that the route is learned to begin with from router 7. Okay, 7 advertises it as ISIS to router 3. 3 redistributes it into BGP. It goes to router 2 and it goes to router 1. Okay, let's assume now that router 2 has received the route first. The route then gets redistributed down into ISIS. Router 1 now says, well, I have an ISIS route with an administrative distance of 115. I have the BGP route with a distance of 200. So I install the ISIS route, which means I withdraw my BGP prefix that I'm learning, and I also start to advertise the route into BGP. So I advertise it back to router 2. Now, this is not the same as reflecting the route. We are locally generating the route, so it means that the next hop value from router 2's perspective can now be router 1 when the ISIS route flushes out. And this process is going to happen over and over and over. Now, there are a couple different solutions to this, but the main issue that it comes from is that we're using both ISIS levels between the PE and the CE links. So if we were using only level 2 or we were using only level 1, we shouldn't see the problem. The other option is that we could filter the routes as they come back in or filter it as we're doing the redistribution. So this is as if we're not doing MPLS at all. If you were to do just regular BGP and ISIS routing in the global table, you would have the same problem. But the main difference between this and OSPF or this and EIGRP, this and BGP within the scope of L3VPN is those other protocols have built-in loop prevention mechanisms to stop this problem. But with ISIS, it doesn't. It means that we would have to manually fix it. So like I said, one of the simplest solutions is don't run both levels or don't redistribute into both levels. So if we were to change the ISIS process everywhere, where we were to simply say under router ISIS 100 that the IS type is level 2, and this is going to be on all of the devices. So let's say on 1, 2, 3, 7, and 10. And we now look at the show IP route ISIS. And let's take a look at this on the other side. So let's clear the routing table again. Let's say clear IP route. Clear IP route VRF A star and B star. Then show IP route ISIS. It looks like we're still having a problem. Okay, we learned 7's loopback. Now we're deleting 7's loopback. Someone is still deleting it. Okay, so let's look at between 1, 2, and 3. Debug IP routing. Debug IP routing. Debug IP routing. Let's see who is specifically causing the loop. It's router 1's fault. Okay, router 1 says I have a closer administrative distance for 777. I'm learning it through ISIS, so I'm going to flush the route out. So the issue is that since there's no downward bit in ISIS like there is in OSPF, whoever redistributes the route from BGP into ISIS first, the other device is going to install it as ISIS, redistribute it back in again, and then we're going to have to remove the prefix. So in addition to just using only one level, this is not going to fix it on its own. We're going to need to go one step further and basically say that when you learn routes from L3VPN, the BGP routes should be preferred over the ISIS routes. Or in other words, we could say for ISIS, let's set the distance to be 201. So you will never prefer that it over the BGP route. So let's say on router 1, we go to ISIS 100 and we say distance is going to be 201 for IP routes. Okay, and let's say this for everybody. So we'll say under router ISIS 100, distance is 201 for IP. And we'll do this essentially on all of them. So 1, 2, 3, 7, and 10. Okay, then if we clear the routing table again, so we'll clear IP route for VRF A, for VRF B. Then we look at the show IP route ISIS. Okay, so let's see, up to 12 seconds, 14 seconds, looks a little bit better than before. So now on 10, let's go ahead and try to reach this. Let's ping 7777. Source is loopback 0. And let's see, does 7 have the reverse path? It does, but what's the problem? I think actually the problem is that router 1 is using router 2 to get there in terms of the the MPLS transit path, and they're going to be looping the traffic back and forth between each other. So what I mean by this is that if let's say one learns the route first from router 3, it redistributes it from BGP into ISIS. Okay, router 2 now says to get to the destination, we're going to go this way. So the packet gets to 1 says the next hop is 3, but the issue is that in order to get to 3, we have to go to 2. So now the looping condition occurs here. So it's partially related to the fact that ISIS keeps installing the routes. It's partially related to the way that this physical topology is actually designed, that since 1 has to transit through 2, it's going to be a problem. So let's say that from 1 we do a trace route in VRF-B to 7777. We should see that's where the problem is, that it's going from 1 to 2, 2 is looping the packet back. So one other way that we could solve this would be to say that on router 2 you have to install the route as BGP, and on router 1 we can install the route as ISIS. So if the traffic were to go from 1 this direction and then up and over, that would be fine, but not if it's going the other way. So it would basically be the same as essentially just disabling one of the PEs, because we can't do load balancing between the two of them based on the way that the physical topology is set up and the fact that they're transiting over each other in order to get to the final destination. Now, one other way we might be able to fix this would be to disable the link between them, so that if we go to router 3, we have to transit up and then back down. That should be fine because we're using an MPLS label as we go through XR2, but router 2 is just going to deflect the packet down that way. So let's say between 1 and 2, we just disable that port. And if we now do a trace, now we're going 10 to 2, and no, it's still looping. So it's going from where? It's going 10 to 2 to 3, 3 to 13. That doesn't make any sense. The reason is that it has the wrong transport label. What is the transport label we're using? It says a 16. It should get to router 3 with a just a 1 label stack. Okay, let's look at the show IP route for a VRF-B. And it says 7777 is via router 10. Okay, it looks like the route is stable, but let's now go down to 10 and see which way it's using. Show IP route for ISIS. It says go to router 2. The route is 3 minutes old. So the route is not flapping, but we go to router 2 and then we show IP route for VRF-B. It says 7777 is via 1111. That's what the problem is. We should be learning this directly from the next hop of 3, not from the next hop of 1. So the reason why 1 is advertising this, though, is that 1 is installing it from ISIS and then redistributing it back into the BGP process. So we basically need to make sure that when the route comes from 7 and goes over here, when we go from BGP to ISIS, we can redistribute whatever we want. But when we go from ISIS back to BGP, we basically need to say that it is not 7777 that is going to get redistributed. And again, this is what OSPF would do for you by default, is that by using that downward bit, you cannot install the route on the table, which ultimately means you cannot do the redistribution. So because of this, as you could probably guess, there would be very limited applications for using ISIS in this manner because it's got no loop prevention. You'd have to manually fix this basically for every prefix that you would want to do the redistribution for. So what I would need to do next is basically on router 1 to say when we go from, we need a route map that is going to be from ISIS to BGP, and it is going to say we're going to deny match IP address prefix list 7 and then permit everything else. And IP address, or no, IP prefix list 7 would say to permit 7777/32, and then also the link between them, okay, between 3 and 7. So permit 10.370/24, and then we'll say under BGP1, address family IPv4 VRF-B, redistribute ISIS level 2, and use the route map ISIS to BGP. Okay, but we need to do the same thing on router 2 as well. So if we show, let's say, show run section route map or BGP or prefix list, which is, and I needed to say ISIS 100. Okay, so router BGP 100. No, router BGP what? 1. So redistribute ISIS 100, and then use that route map. Okay, so this is going to be the identical config on both router 1 and router 2. There's a question here, can we use the site of origin to fix it? It's the same type of logic as we're trying to apply, but the issue is that there's no way to encode the site of origin in the ISIS update. Whereas with BGP, BGP has that installed as an extended community, but there's nowhere in the ISIS type length values in order to tag this information. Okay, so now let's say from router 2's point of view, if we show BGP VPN v4 unicast for all 7777, it says the best path is where? Best path is via 3333. So that fixed it. So now router 1 is not redistributing from ISIS back into BGP, and the only way that we can reach this particular route is to go through router 3. So now let's say from 10, can we ping 7777 from our loopback? Now we can. Okay, let's look at a trace for this, make sure that it's stable. And now in this case, we can now use both exits. So again, this is basically the same exact logic as if you were to have MPLS not involved at all. That if you just had ISIS on one side, BGP in the middle, ISIS on the other, you could replicate the same exact problem by doing it in the global table. But with the other PE to CE routing protocols, OSPF, EIGRP, BGP, etc., they have specific loop prevention mechanisms just for MPLS so that you don't need to do this manual filtering. But otherwise in ISIS, there's no real other good way to implement this because there's no sort of tagging that you can encode in the ISIS update like you can the BGP community or like you can the OSPF down bit or the route tag. Or in the case of EIGRP, it's even simpler than that because we're encoding the metrics inside of the BGP update. When we redistribute from BGP back into EIGRP, the metric would always be higher to use the MPLS network than it would be to use internal. So we prevent the loops just by looking at the lower end-to-end cost. So it is kind of an interesting problem, but this is one of the reasons why you just wouldn't use ISIS. So if you have the option, the ideal case would be to use BGP as PE to CE routing, because as we know with BGP policy application, you can do whatever you want. That you can say, you know, I want to route this way to this prefix, this way to another prefix, and we can change that by using simple attributes like local preference, by doing ASPAP prepending, etc. Whereas in terms of things like OSPF, we have that crazy list of how we do the order of selection and then how we do the route encoding based on how we're doing the OSPF to L3VPN advertisements. And then in this case, we can see ISIS basically just has no loop prevention mechanisms at all. So you would have to manually prevent this anytime that you have multiple PEs that are connecting to the same customer site when we're running IS to IS. Now, if this was only single homed, if we only had it between router 2 and 10 and then between router 3 and 7, we wouldn't have the problem. It's only an issue that there's multiple PEs that are going to the same site and the route is going down and then get fed back and over and over and over.